All right, topic 2. Now, there are 3 types of bonding. You have ionic bonding, which is between metals and non-metals. And to describe that, you say electrostatic attraction between oppositely charged ions. You have covalent bonding, which is only in non-metals, and it's sharing a pair of electrons. And then you have metallic bonding, which is you have positive metal ions and a sea of delocalized electrons. Now, in covalent bonding, you have 2 categories. You have simple covalent and giant covalent. So we're going to look at those together. So first of all, the yellow line separates the metals, which are on the left side of the periodic table, with the non-metals that are on the right side. So anything that is just metallic, such as copper, will have metallic bonding. If something is just non-metal, like oxygen, it will have covalent bonding. But if you have copper oxide, that will have ionic bonding. So carbon, covalent. Calcium is metallic. If you have calcium and fluorine, that's ionic. If you have beryllium on its own, that's metallic. But beryllium with nitrogen is ionic. So ionic bonding, you have a giant lattice structure which has high melting points and boiling points due to strong ionic bonds, or you can say strong electrostatic forces. Also, an ionic lattice will not conduct electricity when it's solid. And the reason behind that is because ions can't move. Make sure you say the words ions, not electrons. That's how you lose marks. Also, when it's molten or dissolved, the ions can move. Again, with ionic, you always have to say ions. A lot of people say electrons and they don't score the marks there. So it will only conduct electricity when it's molten and dissolved, but not when it is solid. Covalent bonding, starting with simple molecular, so these include things like water, ammonia, carbon dioxide, and oxygen. So although you have strong covalent bonds between the atoms, you also have but you also have weak intermolecular forces between the molecules. And those weak intermolecular forces is why they have very low melting points and boiling points. Now, they never conduct electricity in any state because there is no free electrons. So here we're talking about electrons, not ions. In giant covalent, so examples include diamond, graphite, and silicon dioxide. So these are all giant covalent compounds. They have high melting points and boiling points because all they have is strong covalent bonds. They don't have any weak intermolecular forces. Now, the giant covalent does not conduct electricity. So diamond does not conduct electricity, neither does sulfur dioxide, except for graphite. Graphite does conduct electricity because there are free moving electrons, or you can say delocalized electrons, which are between the layers. Also, the layers can slide. When they slide, that makes graphite very slippery as well. Okay, in metallic bonding, you have positive ions and a sea of delocalized electrons. So metals can always conduct electricity because you have, again, electrons that can carry a charge. Now, metals, if it's a pure metal, it will be malleable, which means that it can bend. And the reason behind that is because it has layers of similar sized atoms which can slide over one another. Now, if you want to make your metal harder, then what you do is you turn it into an alloy. And the way you do that is you mix it with another metal or a non-metal. And this means that now you have different sized atoms, so there are no more layers, and therefore it will not be able to slide, so it is harder. Allotropes are different structural forms of the same element. So for example, here you have graphite, here you have diamond. This is graphene, which is one layer of graphite. So if you take a layer, that gives you graphene. And here you've got fluorines, such as spheres or tubes. Now these are all made of carbon, but as you can see, they have different structures, which is why they're called allotropes. So diamond and graphite. And diamond, all the carbons have 4 bonds, which is the maximum number of bonds a carbon can make. However, in graphite, carbons have 3 bonds, which means one electron is free to move around between the layers. And as a result, this is why graphite can conduct electricity, but diamond cannot. Also, graphite is slippery because the layers can slide. Graphene is a single layer of graphite. It is strong, but also light, and that helps, and it's also used in electronics because, again, it has delocalized electrons which can conduct electricity. These guys are called fluorines. You have spheres and tubes, and they have huge surface area to volume ratios, and that's used in drug delivery or as catalysts or even as lubricants. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at examqa.com, where I will personally be there to help answer your questions. Mohammed signing out.